welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. This is the show that goes deep. We go all the way down into technologies, and we don't apologize for it. With me today is AJ Hunyady. He is the founder and CEO of InfinyOn. Welcome, AJ. Would you mind introducing yourself a bit more?
Hi, Jesse. Thanks for having me on the show. I'm AJ Hunyady. I'm what should I say, a technologist, a technology addict, maybe. I've been holding back for years, so now it's probably time to let go. Maybe the show will heal me. So let's see where we go from here. So a little bit about my background. I was born in Romania, from Eastern Europe. I was born during the communist influence at a time where we had limited access to Western technology. One of the most advanced gadgets out there was the HP scientific calculator. I still remember I was 10 years old where I picked up a Fortran book from the library and I started coding on paper. It was pretty enticing to me that you can do some really sophisticated stuff, and they would have diagrams on how this computer would operate. And I wish I had a computer, but unfortunately we had no access to it. So in 1989, the Iron Curtain fell, and Romania, together with other countries, have fallen off of the influence of the communist regime. So at that point, about 9 months later, I emigrated to the United States, and I got my first IBM. I must say I was in heaven. I've finally got to code on a computer. So I've learned BASIC, then Pascal, then C, C++, and the rest is history. So I guess just about a year after that, I was admitted to San Jose State University, where I've applied for the CS program, where I eventually received a bachelor's and a master's degree. So what was interesting at San Jose State is I actually had to carry myself to school. I didn't have anyone that could sponsor it. So I would take night classes, which some people will think, well, sure, but that doesn't really give you the ability to experience college. And that was kind of a luxury for me, given where I came from. So I would work during the day and I would take classes during the night. But actually, that turned out to work quite well because lots of Silicon Valley techies had a knack for teaching. So they would go to work during the day and come and share stories in class while they're teaching us at night. So that's why I've gotten to experience stories from Tandem Computer for IBM, in particular with regards to security and distributed systems. And it didn't take long for me to actually uh, have a passion for distributed systems that actually have been served me well ever since. So I guess it was a long with an intro, but we can take it from here.
Yes, welcome, welcome. We were talking before the show, before we started, about being Romanian because I've been to the place near where you are, not quite, probably not far. So it's called Timișoara, and it's at the very tip of Romania, and really enjoyed it there. And then I've also heard about you talked about the communist regime. There was Ceausescu was the name of the guy, and not the greatest guy, but yeah, yeah. But I've been as I've delved into the Romanian sort of culture and I guess the history, I was surprised with how many Romanians there are because growing up in Montana, I hadn't been around Romanians. And then there's people like you, there's people like Matei, Zaharia, all Romanians that moved over and started these tech companies and do really well. So I'm completely surprised, not just surprised, but I'm always happy to see that.
Romanians have a pretty deep talent pool, I would say. There are lots of companies that have been established, some gaming, some high tech. Uh, as you talked about, Zaharia, is actually he's quite famous as well for his work in Spark and so forth. So it's actually it's a great pride to come from that country. And it's also the fact that you went to Timișoara. Interesting enough, I was born there. I'm from the western part of Romania, and I lived in a small town nearby. But yeah, that's our history. It's a good. Those are good memories for me.
Well, good. And hopefully you're making new ones. And so you talked about that background that you had, and as we'll go through your background, we'll talk about it more. But you have this intense background in networking systems. Why? What makes you so interested in them?
Well, I don't know. I think at the time that I went to college here in the United States, it was really even the early days of the internet. So I really was fascinated by stories of how the TCP/IP was invented and the driving up and down 280 and the communication with Southern California and all these stories kind of very enticed me into learning more about how this technology works. In the master thesis, for instance, I worked on the NewTop group membership protocol, where I built a visualization to showcase how these elements in a group are getting stitched together. And imagine this was early in 1990s, so it was quite novel. There was no RAF protocol back then or anything like that. It was a little bit more basic than that. And it felt like the right space to go in. And as you see, as I'm going through the background, as I've joined networking companies and I joined firewall companies and I joined router companies. I've always been very close to distributed systems and security.
It's interesting. I've seen that common thread throughout my life of people who are interested in networking that actually translated well into the streaming systems because you're used to that communication. You're used to distributed systems. For example, when distributed systems became much more a thing in my life, before that, I was doing a lot of networking, point-to-point protocols, that sort of thing. So, how do you think your background in networking systems translates into those streaming systems?
Well, if you think about it, networking and security, they're both kind of applicable in what we do today. And you see as we go through this that there's quite a bit of correlation. But to me, networking, and I remember from the days when I was at NetScreen, and we were actually building stuff in the TCP/IP layer. So I would have both TCP illustrated books in front of me, and then there would be my references virtually all the time. When you're building firewalls, you're building end-to-end proxies. So you end up finishing the connection on one side and restarting it on the other side. And since you're doing a very small embedded system at that time, you don't have the ability to start processing. You actually have to do everything in one process. Therefore, we actually virtually rebuild the TCP/IP stack. So, why is that important? Data streaming. So data streaming is just it's a payload that runs on top of a networking engine, which is a TCP/IP. Literally, everywhere we're using TCP/IP and we're using TLS because it's all encrypted when it goes over the network. So that's the foundational element. It's always helpful when you're troubleshooting a system to figure out, to actually understand all the layers involved, from the MAC layer all the way up into the transport into the networking. So you're able to identify what are the gadgets, what are the challenges. And today a lot of these software stacks are abstracting it, so you don't really have to know it. But it's always useful during the troubleshooting.
Well, that was going to be what I was wanted to ask you about. Is back in the day, you specifically had to open up a TCP stream or you had a UDP stream, and it was very clear in your code. It's a UDP stream. It's a TCP stream. Wasn't really abstracted. Do you think that as a result of that abstraction, that we're missing something, like that people? I would say most junior developers, perhaps even seniors now, you couldn't ask them, well, what is that main difference between TCP and UDP, for example?
Well, I don't really know whether they're missing anything because I guess it all depends on the domain you're in. I mean, obviously for TCP and UDP for us, it was pretty obvious back in the day. One is connection oriented, one is connectionless. You drop a packet, you have to build an abstraction layer on top to be able to write on UDP. There are advantages and disadvantages for picking one versus the other. Then there are other protocols that were sitting around it, like RTSP, so forth. And the idea is that the abstractions that you currently have are, I think they're helpful in not really have to deal with it. Is it helpful in troubleshooting? Absolutely. But I'm not really sure whether they're losing out of not knowing the differences, where one protocol is better than the other. Where, I mean, for instance, there are other things that are around TCP. For example, it's useful that we know how DNS operates. It's useful that we know how DHCP operates. It was very useful for us when I set up the distributed system to figure out what direction should the connection get initiated on. For instance, we work in the firewall world. We know that firewalls are actually protecting your network. So when we build this distributed system, we realize that all these traffic that connects into the network has to connect outbound, meaning that they have to connect from somewhere where the firewall allows it. For instance, if I'm connected from one data center to another, outbound traffic from the data center itself is allowed. Inbound traffic is blocked. So when we build the system and distributed system per se, we make sure we take that into account. So for instance, when we build InfinyOn, we've made sure that we separate the control plane from data plane, which is not what you see in a Kafka environment where the broker and the controller is actually together. But why have we done it that way? We've done it because of the background that we had, and also because the clean separation between control plane and data plane gives you the ability to have different deployment models. So you can create a hybrid cloud where the control plane is being shared between the data plane and so forth. So we were very deliberate when we build the system about our design decisions, and some of them have been due to our knowledge of the underlying networks, due to knowledge of TCP/IP, due to knowledge of security, due to knowledge of how firewalls operate. So what we've done is we've created this SPUs. They're connecting from the SPU to SE, and then even though the SE is the controller part, the connection itself is actually initiated by the SPU.
That's interesting. You're touching on something that I've been thinking about a lot lately, and it is with generative AI. And I've been thinking about what generative AI is going to do to change, where you have Jensen Huang from NVIDIA, for example, saying everybody can be a programmer. And I keep thinking, because I have a dog in that fight of, so do programmers go away? And I don't think so, because it brought up what you just talked about. Will an LLM or know, hey, you're using a UDP connection, you're using a TCP connection, and be able to, oh, well, that's the reason why you need to do X, Y, Z. Will that eventually happen, or is it just a matter of time? What are your thoughts on that? Given that you had the experience to say, let's separate out the control plane, let's do this. Something I'm not sure that a Gen AI can do or will be able to do, frankly.
Interestingly enough, Gen AI to me, I thought it was eye opener more than anything else. My wife says that I have better jokes and I'm a better writer because I've been using this open APIs, and it seems like it's my co-pilot. Anytime I write something, and anytime I'm curious about something new, I actually go in there and ask OpenAI to give me an answer, it's great technology. And I've been reading up about how they've actually set it up and the magnitude of data they can process in order for you to get insights. But from there to translate into code, into it actually writing code for you, I think we're way off of that. We're years away. I would try to use Copilot, for instance. It does some things right, but it's never quite correct. And the more sophisticated that program you're working on, the harder it will be for any type of an AI to solve it. For instance, I just looked at InfinyOn anecdotally, and in our code base of Fluvio, we have 100,000 lines of code in Fluvio, and now we're launching something new, which is STF, Stateful Processing. That's about 40,000 lines itself. Now, you can imagine the amount of intelligence, the amount of knowledge went into writing that code. I don't really see, no matter how sophisticated Gen AI will be for the next probably 5 to 10 years, I don't see them being able to replace all the business intelligence that have been set up in our system in order for you to get the product equivalent to ours going.
We're in for some interesting times. So yeah, I'm really, really curious about this. But my experience has been somewhat the same as yours. Is those nuanced bugs that it introduces are really painful, especially with multi-threading, especially with if you do the quick glance at it, it looks okay, but there's that one thing that you didn't see there. Hey, it multi-threaded it this way, it did this, it did that. We'll see.
Yeah,
We'll see if
we found this thing, and it's interesting in where we're going to be heading with this, with our product, is that it's you get data streaming going fine. It's been around for a while. You get it going. It's all good. Then you get into the traffic and the data abstraction that are introducing new challenges for you. All of us of a sudden you say, okay, I have duplicates. I need to remove the duplicates. I have time-bound constraints. I have time-bound constraints, and I have to do transformations. I have to do cleanup. And every time you're introducing one of these elements, the problem actually becomes exponentially more complex. And you see the same thing with AI/ML. You think that you can write simple code with generative AI, but as soon as you introduce the next component, the next component, the next component, it becomes exponentially more complex. At some point, is going to tell you, okay, you got to figure it out from here on your own.
Yeah. Well, the times I've tried to use GPT-4, it basically does that. It will just say, this is too complex, and here's some stubbed code, and go figure it out yourself. And I'm like, well, that's what I asked you to do. That I could do that myself. But
And other things that I'm noticing, you tell them to fix something, fixes this, then it breaks the next one. So it's I don't say that technology will advance and it will get better, but will it be able to solve some of the problems that the architects are solving today? I'm not really sure. Maybe it depends on the level. Maybe replace a junior engineer that's writing an interface to something. For instance, I write a connector to something that's just bridging two different protocols. Gen AI probably figure that one out. But writing a distributed system and that has the ability to scale up, has the ability to give you um, some level of self-healing and make it re-entrant, make it have the ability to attach to different storage units, have the ability to recover from fail states. I'm not convinced that will happen anytime soon.
well, that actually brings up another thing I've been thinking about quite a bit, and that is, if you're a junior engineer and you're never given the opportunity to have these experiences and to be forced into these problems, because that's what you and I had to do. We were forced into doing this because we had a problem. If you're a junior engineer and you're replaced by generative AI, or you use generative AI as a crutch, do you ever learn from that well? Have you thought about that?
Actually, interesting enough, I think generative AI is a good learning tool. It will gives you the ability to get off the gate a little bit faster. You can ask it things, and it will do it for you. Now the question is, will you learn from that? Will you actually try to peel the onion and say, okay, why did it actually did it the way it did it, and try to improve from it, or you take it for granted and apply it and move on? Now, if you think about how we operate as developers, I would argue that 90% of what we build is actually copying code. We build it once, we solve an algorithm, we're not going to solve it again. You'll cache it, you'll save it, you reference it every time you have the same problem. And we do a lot of copying. And Gen AI probably would be good at that. Once you solve a problem, if it can learn how you solved it and you tell it that you need it, it can find it and it can use it on your behalf. And when I'm using VS Code nowadays, I have Copilot that actually I type something and here we go. It already gave me the whole mapping to a new structure. So those are things that I learn from my behaviors. So I agree that in some cases we'll learn from your behaviors, but it's in my opinion, it's solving very tactical problems. And even for junior developers, it will solve tactical problems. Somebody has to do the overall thinking, the whole design aspect, the whole architecture aspect, the whole laying down components aspect. Because you could lay down components in a system virtually in hundreds of thousands and millions of ways. The more complex the system, the more ways you can actually stitch things together.
Well, let's start talking about your time programming. You were a heads down coder at CA Technologies and Netcom. It's kind of funny seeing CA on somebody's resume because nobody knows what CA is anymore. But back in the day, back in the mid 90s, that was the place to be. So, what was the most
I
difficult? I'm sorry, go ahead.
I apologize. Go ahead. I didn't. I thought you finished your question.
Oh, I was about to say, what was the most difficult coding experience you hit there?
So when I joined CA, obviously I was still in college. So I joined as a part-time initially, and then eventually I turned into a full-time employee there. Everything was hard. We were we were building. I was part of a team of around 30 engineers, and we were actually building a spreadsheet. So we were building a competition to Excel. And we built it using a modeling engine, and it took us about a year. And eventually, we realized that there's no way we can keep up with Microsoft, and the project got scrapped. But from there, I moved on to Netcom. And at Netcom, what was Netcom? So what was CA and what was Netcom, just for context? CA was actually a technology company that was buying up companies that were either struggling or they didn't quite find a market fit, and they were actually trying to make revenue out of them. So they bought database companies, they bought software companies, and so forth. And you're right, it was the place to be. Their business model seemed to have worked. They could take technologies and make money out of them. I don't know whether they were a pure technology play, which was kind of disappointing at some point because it was easy for them to switch from one project to the other. Hence the reason that I decided after some time that it's time to move to something that's a bit more mainstream. And at that point, it was Netcom, which was an internet service provider. We were actually setting up POPs for dial-up modems. If you remember the US robotics, they were ding dong, ding dong. So you get connected to the internet. And at that point, at the time I joined, Netscape was not even around. So it was still Mosaic. We built our own browser. I still remember we built our own browser for Mac, for Macintosh back in the day, and for Windows before Netscape was around. And also we built our IRC, inter-relay chat. If you remember the days, that was the communication, and you would find all sorts of interesting things in newsletters and IRCs. And we built our own mail server. Gmail was not around at the time, and Hotmail was not even around. So I was responsible for building IMAP server. So I was responsible for the mail, and that's where I had to figure out how PopD operates and how IMAP operates and all the challenges that comes with it, and place it in a usable form and build an MFC application on top of it to get you mail in the Windows format. So it was a challenge, but I spent several years building that, and I thought it was fascinating. I still remember what I've actually added some shortcut keys and in this project when you open a specific dialog box, because that went on the CD and it would be deploying in grocery store. So you get it, so you install it. It was free because they were making money on PopDs. So you do these special codes, and if you do the special thing, eventually you pop up a box saying this code was written by AJ Hunyady, whatever. So that was my prize. So I showed up at my friend's house one day, and he had one of those. I said, "Oh, let me show you something." So I get in the program, I open it up and click all these things, and pop, here comes my name. So that was the intuitive, I guess. That was the genius of the engineer was back in the day, to hide it so my manager can find it, but also be able to show it to my friends when I'm at their house.
Are there any other Easter eggs that you put in that are still around?
Well, obviously that software has long gone, but it was just that's that's the only thing that I could sneak in without being caught.
Uh, this reminds me of something. I was having this conversation at the Udvar-Hazy Smithsonian in Washington, D.C., just outside of Dulles Airport. And there was a guy there who helped build he helped build the SR-71 Blackbird, the one that's the titanium one, the beautiful plane. Anyway, I was talking to him and I was saying, in my career, all the stuff that I've written will never end up in a museum. And it's kind of weird that as I was standing there talking to him, I had that realization of everything that we've written, everything that we've done in our careers. My kids won't be able to point to it and say, "There's the CD of the stuff that Dad did." And it's just kind of weird that our software is so ephemeral. Where we talk about Netcom, not just it doesn't exist anymore. And that CD doesn't. It's in landfill somewhere. But
Yeah,
that's about it.
yeah. Well, I guess that's why Google decided that they're going to they're going to take all the books and scan them, and they'll have a digital footprint of everything, because a lot of our coding, a lot of our stuff that we built, it's gone. And if I reference back, at least you want to have it for historical purposes. It'd be fascinating to still have access to that, but you don't even have the software to run it on, even if you
Yeah.
have the CD.
Yeah. Even if you had the CD, there, where are you going to do dial-up? How are you going to do dial-up? I
Exactly.
don't. I don't even have a home phone anymore. That's how much
Exactly.
things have changed. Here I am with my
Exactly.
gigabit internet connection on fiber channel. So, speaking of things gone past, what do you think has stayed the same and or changed since the '90s? Technically,
Well, I'll probably one of the things comes to mind is that page from Andreessen Horowitz's book is like software is eating the world. I think that stayed. Software is actually it's really genuinely eating the world. It's everywhere. Everywhere look, every hardware device, I mean, every app that you're using, it actually has some sort of software that was written by somebody, and it's only to go. It's there's only going to be more software because there are more gadgets being invented. There's this pervasiveness or IoT where everything will communicate, including your clothes probably that need to be washed at some point. So the number of gadgets, the amount of software that's going to be written, it's mushrooming and will continue to do so in the near future. Second thing that comes to mind when I think to that is that top engineers are still worth their weight in gold. If you think the generative AI will replace it, I just don't think that'll be the case anytime soon. And the top engineers that you can find is just they're just the creativity that comes out of them. It supersedes probably anything that the Gen AI will be able to build in the next 10 years. And maybe the third thing that I'm thinking through, I guess startups is still the place to be. It's still the most innovative places on earth, even though you look at AWS and Amazon and you think that, my gosh, these guys are innovating at a tremendous pace. But I still believe that if you want diversity of technology, if you want to learn fast, you want to be in a startup. So these are the things that kind of stay the same in my view. Now, what is it different? Innovation is at all-time high. I think that's changed tremendously. The number of startups back in the 90s compared to the number of startups that get funded now, I would think it's exponentially higher. Now, with the parents of GCP and AWS and all these IaaS infrastructure as a service players, you can get a startup off the ground with virtually no money. And even if you need some money because you're trying to build something that's actually more resource intensive, more often than not, you can go into AWS and get credits. They give you 100K or GCP, and you're able to get off the company off the ground and with relatively easy access, with relatively easy need for resources. And I feel like there is a lot more seed money available. Every one of my friends that had an idea and wanted to try it, he found a way to get money. So it feels like hiring a small team, getting something off the ground, it's never been easier. So that's my mind. I think what has changed is US and Silicon Valley and probably overall the whole technology sector is really encouraging startups to get off the ground. It's really encouraging innovation, and it's great to see that has changed from the 90s when we were trying when I was even thinking that startups are an impossible thing. So
well, even if you go back to while you were still in Romania, some of my Romanian friends told me about the internet cafes, and it wasn't just that there wasn't startup; it was there wasn't computers anywhere else, so you would have to physically go to the internet cafe, and that was how you met people, and that was how you checked your email. Uh,
yeah.
we didn't have as much
Uh,
internet cafes in the U.S., but it was definitely Romania, right?
Oh, they were in the 2000s, in around and I think it started in around late 1990s, early 2000s, the time that I left. So I would go back and you had these internet cafes where they were specialized because computers were expensive. You couldn't really afford one. So then you'd go to these internet cafes that were specialized in gaming and communication in general. You would do research there. You would communicate with your friends there. So I would have a friend that would go to the internet cafe every once in a while, communicate with me over IRC. So yeah, that was definitely a thing. When the computers were expensive, that was the only way to get to one is to go to an internet cafe.
Well, so from there, you went to NetScreen Technologies and Juniper Networks, and you went from an individual contributor to management. What made you do that transition into management?
Um, I think It took me a while. I was a developer for about 10 years before I became a manager. And what drove me to it, I think it was the influence. I felt like I was always being told what to do, but I never really consulted what was the right thing to do. And I felt like if I become a manager, my level of experience, but influence will increase. The ability to lead a small team and eventually a larger organization will give you the ability to be able at least to save my peace, to tell people what I believe that should be done, and hopefully they will listen. And as I grew and as I became a VP at some point, then it's that I was able to also get exposure to the business, which at the time I became a manager, it wasn't like I want exposure to the business, that's why I become a manager. But as I became a manager, I realized that's a more important aspect of this challenge. So it's you're individual contributor, you're typically building something, you may not have the visibility in the whole picture. As you become a manager and you're hired into the organizational structure, and then you're part of those conversations, you connect the dots between what you're building and the business opportunity and the revenue that comes with it. So you're able to make better decisions. You're able to understand how what you're actually building and what you're telling other people to build are going to contribute to the bottom line of the business.
Yeah, I find that interesting, and it's almost a shame that we hold that back from the individuals. But I can see why that your individual contributors you don't want to have that. And that brings into another question of: do you think firewall creation is very similar to real time data systems creation?
I think there are a lot of similarities. I think they're not exactly the same thing because they tackle a different problem. But you have things like they're both high performance systems. You cannot build a data streaming system that is not high performance. Nobody will deploy. Firewalls have to be high performance. They're both handling business critical data. You deploy a firewall that's actually in the middle of your network, actually the edge of your network, to make sure that it protects your data assets. You with the data streaming, you're sending business critical data. So you want to make sure that you have the right level of reliability. It's very important, and performance. They're both dealing with encryption and security to some extent. So I still remember that and I was working back in the day on VPNs, IPsec, and then X509 certificates. And we are using some of those concepts now. Actually, interestingly enough, we're building mirroring. And one of the work items was how to generate a certificate. And how do you get MTLS going? The ability to create a mutually authenticated channel. So you get both authentication, security authentication, authorization in the channel itself. Then it's about traffic management. They both do deal with traffic management. In firewalls, you have to identify what routes the traffic take and what do you block, what do you allow, what translations do you do. In data streaming, if you're building stream processing and you do transformations, you do traffic management, you do traffic proxying. So it's traffic proxy is a big one. In firewalls, you're terminating a connection and restarting a new connection on the other side. So you're able to identify things like attacks. For example, are you on the scene attack? And you sync cookies, you need proxies, and so forth. You do the same thing in data streaming to some extent. You're creating connectors. So you create a proxy, you connect with an edge device that could be a database or another streaming platform or a message queue, and you're connecting it to your own system. So you're building these end-to-end proxies that do various type of transformations on that. So there are quite a few similarities as you can see between the two products.
There definitely are, and I've seen that as a pattern. So another person who is on the show, Karthik Ramasamy, that's his background.
Ah,
His background. Do you know Karthik?
he's in Juniper, isn't he?
Uh, uh, well, you might be thinking of a different one. He's at Databricks now, but
Oh,
I
okay.
think at one point he was at Juniper. I can't remember, but yeah, he's written a networking book as well, and that was his background. So you find this consistency in background. I've always enjoyed that. So from there, you went to a company called Spider Cloud Wireless, and you had a quote that was interesting in your LinkedIn. It was, "I was tasked with bringing cohesiveness to a team of many ex-managers who thought anyone other than engineers was overhead." And it's weird that it was ex-managers saying that about themselves, basically. Tell me more about this.
So, yeah, interesting story about Spider Cloud. These people that I had to manage, and I was brought in to just to be their manager. They were hardcore routing experts. They are the former Juniper and Cisco guys. And virtually, they probably took 75% of the people that built the routers and brought them into that company because the manager at the time, he actually was the first VP of engineering in Juniper. So when he started this company, and he was a co-founder of it, and he brought all these people with him. So why did these people become managers? I don't even believe they signed up. They were manager adverse, even though they have been one. They they became managers at the time where routing business was very hot, and it was growing at a rapid pace. So I guess they were managers by necessity, because these routing companies have taken their best people, and they made the managers to nurture the other people so they can grow the business. So when they left Juniper or Cisco, and what they did, they couldn't wait to get back to individual contributors. But since they had some management acumen, they knew how to give a hard time to managers. So I guess I really had a very hard time with that. So they brought me in because I believe that they saw that I have the right technical chops, so they wouldn't respect anybody that didn't know anything technically. And I had enough management experience to be able to bring the two things together and find a way to herd the cats, so to say, and deal with all these ego problems and make them into a cohesive team. And I believe I've done that. They have not pushed me out. They work with me. I decided to leave in about 9 months to a year after that, because there was something more interesting for me to do. But it was definitely a very interesting time of making it with people they're not the easiest to work with. In particular, they're very bright, and they build some really amazing stuff. And they will not. You have to figure out how to manage them without that feeling that they're being pressed or pushed, or you have to use white gloves, so to say.
I I've seen what you described before a few times of let's take our best developer and let's make him a manager because somehow that translates. And I never have understood what is that calculus that says this translates well, where coding translates into managing humans. And more often than not, probably 99% of the time it does not. And every so often it does translate, but it's a person who's volunteered for that rather than has been conscripted into that.
Yeah, it feels that way. If you are becoming a manager not by choice, but just because that opportunity is there and I think you're gonna experiment with it, people need to realize when they sign up for the job, it requires a different type of a skill set. You have to develop your soft skills. You have to be able to communicate better. You have to be able to convince people of things they may not be comfortable to do, because that's where the company needs to go. And a lot of these engineers, they're very bright, and they 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 believe strongly in what they do. They not don't necessarily have a developed EQ. They have a highly developed IQ, but not necessarily the EQ, which comes back to hurt them at times, where they grow the team and they don't have the skill set required for them to manage a group. And then the old adage, people join companies but they leave managers. That does happen, and it does happen because some of the managers are really not. They don't have the skills required, or they have been trained to become managers.
And it looks like you did the same thing because you went to Gigamon Systems after that, and your quote from LinkedIn was turned a small team into a self sustaining, multi layer organization of 60 plus engineers, managers, and architects in under 3 years. What does it take to go from a small team to a big one?
So I think when you start from a two pizza team, there were about 7 people when I joined, and there were about 70 at the time that we went IPO. And when you're building an organization from it, you start from a single team and you're trying to build layers. And when you build layers, then you have to learn how to manage the influence, which is quite a transition. It's not, and you spend a lot of your time recruiting, as you can imagine. If you're hiring 60 people and you hire out of every 10 because you want top talent. A lot of your time is actually being spent in recruiting. So that means that you have to, when you're growing rapidly, you have to build a second layer that can run the business, a second layer that can develop their own teams, the second layer that can help you recruit. So making a transition from single team to multi teams to an organization where you have to manage to influence, it's a bit of a challenge. And you have to do it well, and you have to hire the right talent at that level. You actually have to hire proper management, and you have to hire proper management that can do planning. And some of that we run into this company as well. You want to keep organization flat as much as possible, but you have to do proper planning. And planning and management is not the same thing. So it's management is more about leadership in my book, and planning is more about assigning tasks and make sure they get completed, which is in my mind there's the leadership aspect, and there is the day-to-day activity planning and kind of the task management aspect.
And from there, you went to E8 Security, and you started doing Hadoop there. And so I was surprised about you doing something with security that was batch, which is usually done in real time. So how are you using a batch system like that?
So okay, there's a history behind why we've done it in batch and we've done it on top of Hadoop. So let me take you to that so it kind of explains. I thought that there is a need for actually what did we try to build at EA Security? We're trying to build the next generation SIM, because SIMs were very difficult to use in large enterprises. You collect logs, you do analysis on the logs, and at E8 we are trying to apply machine learning to be able to do kill chain detection. So you're able to do predictions on, first of all, identify security vulnerabilities and predict areas where you have to address. Now, why did we build it on top of Hadoop? Because Hadoop was actually notoriously difficult to get data out of, and we found that the hard way. And so that's why we were even looking at Spark. Yeah, the idea was that I joined EA Security, which was part of a VC. So it was incubated in the Hive. And what was the Hive? It was a big data incubator. So they were actually betting that big data will grow, and therefore there'll be lots of businesses there. So they built a business plan. And the business plan was created to run on top of Hadoop system because that was the incubator, that was the purpose of the incubator. We realized that we built all these scripts, machine learning scripts, we will do all these map reduce jobs, and it will virtually take forever to run. At the time I left, I didn't stay back long because I didn't think that Hadoop was actually required in that. We could run machine learning jobs on a MongoDB system because all we use the Hadoop is actually for storing the data. So the idea was that if you had used MongoDB, it would have been 10 times faster, and I didn't have to drive down to Fremont and keep actually racking up servers on our data center that we bought managed services on, because we had to get Hadoop running and we have to remote manage and we have to keep going there to hire more server to rack up more servers for just doing simple MapReduce jobs. So it was an interesting experience. It didn't require Hadoop, but I learned a lot from it. The fact that we've done MapReduce, the fact that we're ingesting at high rate, it helped me figure out what I want to do and what I don't want to do, and also figure out what the need is in the market. And I didn't think it was in the Hadoop. I thought it was in the need to just be able to do easier deployments, be able to do a faster traffic processing, and so forth.
Well, I'd agree with you. I was seeing that at the time too. I was seeing that need of the batch sort of mentality, or the batch was inherently limiting because I was used to a lot more real time systems, and this slowdown in batch, this hour long, 24 hours, it just didn't. It made it so difficult to do something, to make action, and similar to what you were hitting. You can get it in, but it's that last mile problem of getting it out.
Yeah.
So from there, you founded a company called Zockets, and that was eventually acquired by NGINX. Why did you decide to found a company?
So we were at the EA Security, and that's where I met my co-founder, Seo Chang, who was probably the best engineer I've ever worked with. And he ran across this thing called Docker. It was just announced. It was in the early days. It didn't. Swarm was not even around. And we kind of liked it for packaging. We thought, oh, we can write our software in there, and it's kind of cool. Then CEO came up one day and said, you know what? These Docker guys are infrastructure guys, and they don't really know how to build a management system. It will take them a long time, and I think we can do it faster. Why don't we try one? And we thought about it for a while and said, all right, well, let's do it. What's the worst can happen? We're just going to look for a job in another year, and that's the end of it in case we fail. So we went out there. We raised $1 million, and just about $1 million. It wasn't quite that much, and we found the Zockets. We said, okay, let's build the management plane. So we started building a management plane. Docker Swarm came out. We were actually building an application wrapper for containers. So you stitch a lot of them together and have them run as Unison. And because we felt like, coming from a world where microservices seem like the right way to go, it felt like containers are the answer to that problem. And we're going to get back more into that a little bit when we talk about NGINX. But we realized that this is going to be kind of problematic when Kubernetes came out. We were thinking at the level of abstractions that our persona we're going after had no interest in. So we were building an application level abstraction, but the people that actually were really intrigued by this technology were people that were trying to run networking systems. There were people that are trying to set up Docker container management for applications that are built a little bit differently. They were done through service the service distribution and etcd and using etcd to be able to deploy them and be able to communicate between them. And when Kubernetes came around, we thought, oh, we're in trouble. Our abstraction is not going to take off because Kubernetes is the way to go. And we didn't have the foresight to create something that they have. And at that point, NGINX came around, and we were at DockerCon, and they liked our management plane. And I said, oh, gee, we need a management plane for NGINX. So why don't we join forces? And after a few conversations, I really liked Gus Robertson, their CEO. We had lots of good conversations, and they told us that we can build a management plane on top of NGINX so we can continue what we're doing. We liked that, and here we go. A few months later, 18 months into the journey, we're acquired. And when NGINX sold to F5, and our investors made a bit of money, and everyone came out ahead as part of that acquisition.
Well, good. Glad that it worked out well for you. So that transition from NGINX, I didn't realize that NGINX was a company until I was looking through your LinkedIn profile. I thought it was just an open source project.
Now it's no longer a company. Now it's F5 is the company, NGINX is the technology. They were acquired by F5.
But even when it was, I didn't even know that. So there at NGINX, you became head of the microservices architecture, and I'm curious, do you think that our microservices architecture was or is overused?
At the time I was there, I thought that microservices were the way to go. I felt that if you have a monolith, then obviously the whole Netflix transition to microservices paid huge dividends for them. And I bought into that. I believe that microservices is the way to build applications. Now, a few years later, I'm thinking that microservices is one way, but it's not the only way. In some places, you don't need a microservice. For instance, if you start a company off the ground, you could start with a monolith just fine and distribute the microservices when you hit a certain scale or when you end up in the spaghetti code type of an environment. But if you have good development practices, you don't need microservices everywhere. But microservices, indeed, they are valuable in large distributed systems. But there are large companies out there, such as maybe, I don't know what I can't give names out there, but there are some financial services companies out there that have huge monoliths that are using today, and they have millions of users, and they still have to deal with that monolith, and it works. They scale it differently, and it works. Now, I'm not saying that they wouldn't benefit from having them in microservices, but as you imagine, if you have a monolith that does thousands of functions and you build them in thousands of microservices, you'll end up with a different problem. You'll be able to scale all these components, but stitching them together, it's a challenge, and that's where it comes into the service mesh, which I've done at NGINX after I transition off the management plane, and maybe that's something we'll talk about next.
Yeah, we'll talk about that in a second. But yeah, you touched on exactly that, where the first time I was probably around the time that you were there, I was teaching at a large bank, an e-commerce bank, and they were showing me their microservice architecture, and it was, hundreds of microservices and the interactions between them. And I thought, oh man, you're going to have what you took from code of all these class inheritances and these calls, you've now made that distributed. And that doesn't necessarily make things easier. You can change the other side, but you're still going to have similar problems. You can now scale that, but there's a lot of other difficulties. It's a trade-off. It's not, you don't get something for free with microservices.
For sure. And yeah, the service mesh was supposed to solve some of the problems.
We'll talk more about that service mesh then.
So,
Tell me more about the service mesh and how it would fix everything.
so I was at NGINX at the time where Istio just came online, and Linkerd was really a hot company, and it was all about side proxies and service meshes. And the promise was that the sidecar technologies will solve a lot of the problems the microservices introduced. The ability to talk to each other securely, and then they give you service breaker technology, circuit breaker technology. So when microservice in the middle fails, then you load balance them, and you're going to be able to fail over, and you don't get any downtime. Well, that worked fine if you have like a dozen or so microservices, but it didn't work so well when you actually have hundreds of them. I mean, no matter what, I mean, the ability to deploy multiple microservices and have them communicate flatly to API gateways, to me, was like it's a jungle of mess that you're going to have a hard time trying to untangle. And you'll see that the more microservices they have to communicate with each other, the harder it becomes. And I remember in the early days, I spent quite a bit of time at Google, at IBM, convincing them to use NGINX as a sidecar proxy, aside from Envoy. And unfortunately, I failed, but it wasn't for lack of trying. They were quite convinced that they don't want the commercial product in their stack. They want something that's open source, and Envoy is the future. But anyways, that's I guess I sidetracked a little bit. But the idea is that while we were building this service mesh, we ran across Kafka, and we thought, gee, well, it feels to me that the technology the service mesh is using should be probably better suited if you build it on top of a Kafka message or a message broker, because it's one thing to build synchronous services that actually have an API gateway that you actually have to do a synchronous call for and wait for response. It's quite another to move to a publish a subscriber model. When you do work, you publish the result to a stream, and the next entity will pick it up, do work, publish it in the stream, and so forth, and chain it that way. You chain it through the stream instead of exchaining it to API gateways. So it felt to me that's the better approach. And that's where we got the aha moment. Thought, if this is the better approach, then why don't people use Kafka? And it didn't take us long to realize why not. I mean, Kafka was not, as you know, Kafka was built in a big data era. It was built where it was built for log management, for doing ingests. And it's like, if you remember the Flume days.
Oh, I remember
and
the Flume days.
It was built. Here we go. Yeah, so it was built with Zookeeper, right? It was built with all these big data in the big data paradigm, with big data services. And it was Java, it was Scala, it was heavyweight. It took a long time to bring up. It didn't work as a sidecar proxy very well. You had to really spend a lot of time persuading it to work in Kubernetes. And we felt like Java is a non-starter in microservices environments because it's too bloated for what you're trying to accomplish. And it also has like this garbage collection that you constantly have to tune. And that's where the aha moment came. It said, oh man, there is a need for a better Kafka here. There is a need for something that does similar functionality, but maybe does it differently. It builds it cloud native. It does it with declarative management, to take some of the good things from Kubernetes, move them over to data streaming layer. It gives you a clean separation between data plane and control plane. It's highly distributed from core to edge, so you can scale it easily. You don't have to just be blocked by Java. And that's why we left and started InfinyOn.
If you don't mind, let's talk more about what InfinyOn and Fluvio is, and we'll do that via the whiteboard. So, if you would you mind diagramming out what is InfinyOn and Fluvio?
So let's just start with saying a little bit about what is InfinyOn and what is really InfinyOn. And if I were to tell you what InfinyOn is, I would say that it's an edge-to-core stream processing infrastructure for developers. Why is it edge-to-core? Is because it's small footprint, because it can go all the way and you can run into the core, you can run in the edge, and it's streaming for developers. Why? Because it gives the ability to add programmability on top. So if it is for you to place InfinyOn somewhere and you're trying to replace something or trying to think, how should I think to this? Well, edge to core, what does it mean? It means that you have at the edge, let me see, am I starting showing?
Yeah, it's showing now.
Here we go. Here we go. So what does edge to core mean? You have typically communicating from the edge, you have an MQTT. Then you'd communicate, if it's data streaming, communicate into a Kafka. Wow, my writing is not great here. Then you go into a Flink if you want to do stream processing.
Are you using the app or using the website?
I'm using the app.
Oh, you are?
Am I? Yes, I'm using the app. Yes.
Okay. Yes, sometimes Jamboard can be finicky, but yeah, it did pop in there. Okay. I'm sorry.
Takes a little bit of time. It stopped. I actually wrote more than it actually showed.
Oh, really?
Yeah. It's MQTT. There's Kafka. There's Flink. There's microservices.
It just popped in with a fourth one. You've done even more since then?
I just typed the fourth one.
Okay.
Which is microservices.
How about
Let me start again later.
Yeah. How about this? Actually, I'm gonna force close if you will force close as well, and we'll come back in.
Okay.
Just in case there's who knows what going on.
Yeah, I have the Jamboard app, which I downloaded.
Okay. Yeah, I got that. Maybe it was on my side. Maybe it was. So you're gonna. So if I'll just erase this, and if you would.
Wow, it's terrible writing too. I tried to do better.
Well, you will get marks for penmanship or bad penmanship. Okay, go ahead.
Right. So if you think through Fluvio, what does Fluvio do? It gives you the ability to do end-to-end edge-to-core event stream processing. So when you do edge-to-core, there are two components that typically you have in a network. You have MQTT. Then you have Kafka. That's what gives you the streaming. Then you have Flink. That gives you the ability to do stream processing. And somewhere on the path or somewhere in the place, you're going to have microservices. With that, so this is an R, services that allows you to add your business logic. I apologize for my bad writing. It's very difficult to actually do that here. So the idea is that in order to do this, you have to actually have a system that does multiple things for you. And this is the problem that actually Fluvio intends to solve for you. It gives you the ability to do all these things in one product. So if you were to erase this, then I can start showing you the data streaming stack that Fluvio offers you.
So how about let's go to 2.
Here we go.
Yeah.
2. Here we go. Okay, so let's draw out the Fluvio architecture. So if you look at Fluvio, Fluvio has multiple components. And at the most basic layer, Fluvio has the data streaming layer. So let's just write that down there at the bottom. So it's data streaming. What does data streaming give you? So data streaming, gives you the ability to do multiple things. First of all, it does partitioning. I'm just going to type them like that. It's a bit too much. Replication. This is a C. It gives you storage, the ability to cache the data streaming elements. And on the left side and the right side, it gives you the connectors. On the left, you will have ingress connectors. And clients. It's client and the CLI as well, because it gives the ability to produce and consume from it. And on the right side, you have pretty much the same thing. Connectors, clients, and CLI. So this level, why is this level important? This is where you actually do the communication. So you're able to bring the data coming in, you do the translation for various connectors. There are multiple connectors. You have connectors, you can have Kafka connector because you're communicating from a Kafka protocol. You can have an MQTT connector. You can have HTTP connector or the webhook. So the whole purpose of these connectors is to actually bring you the data coming in. Bring your data into the system, then apply data streaming. So in the data streaming itself, then you're able to stream data, to do partitioning, to do traffic replication. You're able to store the data in a data streaming itself. So it's, if you think of how a Kafka system operates, you have the ability to store based on offsets. It's immutable. It's append only. You get in the stream, then you do some processing on top on the next layer. So this is the first layer, data streaming layer. Now, what is important about this data streaming layer is that you have the ability to do programmability on it. So connectors, for instance, they're smart connectors. So we have a concept called smart module. Maybe I should put my, this is standing out. That's why I probably cannot type very well. So I apologize. I'm just gonna look down and have it on my knees. But I'm not sure whether it helps. You can have something called smart module. So let me erase this and try again. I don't know whether it helps. I tried, and my writing is kind of terrible.
But we're giving you low marks for penmanship.
Yes. The smart modules are programmable interfaces. So you're able to apply your custom logic. You're able to apply custom logic for transformations, for mapping, for filtering traffic out, and they can apply to connectors, or then it can apply to the data streaming itself. The connectors have ingress, then have egress, and so forth. I promise you that if I was working on a board, this would be a lot cleaner. So, but I don't. So this is the ability to create data streams and create simple transformation. It's actually done on the data streaming layer. So next layer up is the stream processing layer. So what does stream processing really mean? It means that now you have the ability to take a data streaming layer and create bounded context on it. Bounded context. What does bounded context mean? Is we call this, what does bounded context mean? If you're familiar with the data model paper that actually was written by Google, and it was actually implemented by a lot of the vendors in this market, it's like such as Flink and various others. It gives you the ability to take a stream and put it together in a context that you can start applying processing on in a table format. As you can imagine, when you're actually collecting things on a table, you cannot do processing and you cannot do analysis if actually you don't have it bounded. For instance, you cannot count how many elements are there in a stream that continuously come at you. You have to create a bounded context, and typically that's done through some sort of windowing mechanism, through check marking, and after that you pick it up and you operate on that data set. So we implemented something called SDF, stateful data flows. So the state of data flows, now we can help you create a data pipeline and operate in that bounded context. So through stateful data flows, you can have things, and I can show you a diagram that's probably easier to do than
Well,
here.
let me ask you a few questions about this before we go on to another diagram. Are you done drawing this out?
Well, there's a lot to this, unfortunately, and I don't really know how to put it in here. The STF, it gives you the ability to create your own programmable logic, and you're able to do traffic splitting, to do merging, and so forth. So in essence, what you're doing is you take this topics, and you're applying these data pipelines on them, which is a different level of abstraction.
I see. So in some ways, you're creating a topic. So you could do a fan in or fan out, for example.
Yes. So there are a lot of there's in stateful data flows now. What do you have? Instead of the data flows has actually two components. It has a YAML file. Okay, that's great. Okay, that then shipped. Let me write it properly. You have a YAML, and you have a series of packages. So the YAML gives you the ability to create your data flow. You think of it as GitHub Actions. This is where you have where you can start representing all these elements. For example, the topics that you just mentioned. How do you split traffic? How do you join traffic? How do you create these packages? The business logic which actually stored in packages. And when you have packages, you can have a bunch of them. And all these packages are actually being built being imported in the data flow, so you can create your business logic. I'll pause now so you ask any questions.
Okay. So let me go back here on the storage. You were talking about storage. This is storage of blobs, or this is storage of topic messages. What is that storage?
This is storage for topic messages. So if you
Okay.
think of the storage, this is actually gives you persistence. So a data stream, it's an immutable queue. So you're writing from one end, you increment, you're incrementing the offset, and it gets saved in here.
So it'd be similar to a Kafka partition at this point, or any sort of partition. Okay.
It's that's just Kafka partitioning.
And
so on top of this is where the replication happens. So these queues, which is actually each of these streams or each of these message queues are a partition. So this partition gives you reliability, first of all, because it's actually saved, and gives you assurance that it's an append only. So there is some ordering in place. And this partition actually is the one that gets replicated across multiple SPUs. Because in the data streaming component, we have the concept of SC, which I mentioned a while back, and SPUs. So these SPUs, they're just like, there are multiple SPUs which are actually dealing with the data streaming per se. So when you do replication, you can take one of these storage components, which is a partition, and replicate across multiple SPUs for resiliency.
Okay. And so we have these connectors, these CLIs. This is how we're getting data in. So if you were to think about it, you could have Kafka going into Fluvio and then doing this processing that goes out to some other place for consumption. And you started talking about your data flow language here. To be clear, this is just defining, for example, input topic, output topic, that sort of thing. It's not actually coding here. Coding is happening a separate place.
Well, coding is happening in packages. So you have two ways to do YAML. So YAML, you can do inline coding, which allows you to express your business logic inline, or it allows you to do composition. So in inline, oh my gosh, this is not great. In inline coding, then you're able to write everything pretty much as you see it. So for example, if you want to do a simple transformation, you just apply the filter. You apply the filter, you apply the transform, you type it inline, you get the record coming in, the record going out, goes into the next topic, and you can chain it with another function if you'd like. So that's
Okay.
what you can express in a YAML. So in the case when you're actually building stuff inline, that the whole YAML is one representation. You just apply it, and all the topics are being created for you. All the business logic is being applied. All you do is produce to the topic, to the ingress topic, and the whole chain of logic would get applied.
I see. So this is almost your DAG creation. So your directed acyclic graph of you goes from this to this to this, and through this code line or through this code package, and then there's different ways of outputting that. Okay.
Exactly.
So this stateful processing, a lot of times in processing real time, we're having to deal with state. So am I understanding that state well correctly, that I could keep around data for the last, let's say, last key that came in, or last whatever I wanted, and it's an arbitrary state that I can keep?
Absolutely. So you have two ways, and that's why maybe SDF would require a new page. But one thing,
Yeah,
what
let's
we
go to
do
the
is,
new page, because yeah, I think once you get into state, then things get more difficult.
yeah, it gets pretty complex. So the idea is that you take packets coming in from a stream. I'll try to draw a little bit better. So stream. My R's are terrible. Okay. You take packets coming from a stream, and you start an SDF service. So what the SDF service can allow you to do is apply your business logic, which takes a YAML. And let's just focus on inline at this point. So the YAML has everything. It has your business logic. It has the ability. It has the DAG. So the YAML has the DAG, your business logic, and the ability to read from topics, write from topics, and so forth. So the first thing it does, depending on what functions you have. So when you're building this business logic, we have a bunch of primitives. A bunch of primitives that you can implement yourself. So the primitives that are opinionated to the platform are the following. You have filter, you have map, you have update state, you have assign key, you have partition, you have all these things, right? Assign key. You have partition for partitioning, for making sure that partition data multiple data sets. And these partitions are different from actually the topic partition, which is the stream itself. They are partitioned the data at a higher level of abstraction. So why am I writing this down? Because within this update state element is what actually you're creating your bounded context. So if you're using filter, if you're using map, or you want to do a split or a merge, and those are also primitives, split and merge, you're dealing with traffic routing. When you're building with state, now you need to create a state object, which gives you the update state. So what does update state mean? Is this data streaming is actually SDF to update state. Is now taking your streams and converting them to arrow format. Which in essence, it's creating it in a table, right? Because the arrow format is columnar format. So now you have the ability for this state to apply third-party products. So you can get functionality on top. So for what we're really doing is we're to this arrow format, we can apply polars or DuckDB. So you have the ability now to perform interesting queries, computations on top of the arrow format. So as you can imagine, and by the way, SDF is currently in beta. It's in preview, not even in beta. We have currently in preview 9, we're adding these components. Now we're adding joins. We have the ability to do joins. We have the ability to create these outcomes on the data stream itself. But when you're updating the state, your typically update state is a step in the window processing. So for instance, how do you update state? You have two choices. One is you update state one record at a time. A record comes in, you just continuously adding it or removing it. That's what the events of the data stream says that it should be doing. Or you can create window processing. And you're building analytics in that case. You're saying, just as Flink does, I'm trying to get a bounded context. What happened in the last 5 minutes? Maybe I'm interested in counting cars in the last 5 minutes. I'm interested in counting transactions in the last 5 minutes. So then the window gets opened. Every 5 minutes is going to get closed, and it's going to be transformed to arrow. And from arrow, now you're able to apply polars. You're going to get a flush method. And within the flush method, you're able to do some processing on it. So for instance, you want to do a sum, you want to apply an AI/ML if you'd like, and so forth. So all that can be applied through the YAML composition and your own business logic on top.
Makes sense. So just to ask a few questions here. So we've got this stateful data coming in, and we're updating our state. This state, this arrow format, is it up? It's updating on disk or it's updating in memory, because arrow can be an in-memory store as well.
So this is updating in memory, but it has backup to the disk. So just what happens over here? There are a couple of things that are important, and there's a lot more to this. So for instance, it's updated everything is resilient. It's updated on the disk, it's updated in the memory, but it can be rebuilt because we're actually building it from the stream itself. And we're taking checkpointing. So what is important when you're building a DAG and you're building stateful processing? A lot of people actually miss this when they're building their own services. When you build your own services in Kafka and you build your own microservice on top of that, you have to keep track. Anytime you do a DAG, you have to keep track of your access manager. You have to keep track of the state that you currently build. And you want to make sure that the two of them are deterministically kept together. So what we do under the hood is we keep all that together for you. When you're building multiple services that are being chained, we keep the location of the offset management to last thread, and we keep that persistent. And we actually building you the state that, as you mentioned, this is in memory initially, but it's checkpointed periodically to the disk.
And it's checkpointed in its entirety, not just here is a place and time. People who may not know this or may only know Kafka, for example, Kafka streams, this checkpointing does not happen. This is a really, 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 really key thing that AJ is pointing out. Those of you who are doing this, you should be paying attention to this part.
Well, the reason that actually that's very important is because when you build a DAG, you're actually taking over the service representation from the user. And you're telling them everything that a service needs to be resilient is we are going to take care of for you. That's why when a service, and we actually have, when you're using STF, you have lots of troubleshooting techniques. You have lots of troubleshooting CLIs. You can actually dump the state of the table. You can dump the state of the offset. You can dump the state of the window as it's being built. We are dumping matrices. How many successful processing elements you have, how many unsuccessful processing elements you have, because you could have business logic problems. So all these things actually this is what SDF will take care of for you. It gives you the ability it gives you the offset management for you. It gives you the ability to create these tables. It makes these tables highly resilient and deterministic. Even if the service restarts, we're going to be able to resume from the place that actually left off. So if you run multiple services and one goes down and comes back up, it's going to resume where it left off. So each of the service element has its own offset management that reads from a specific topic, and it has its own location. For example, if you have 5 services that are communicating, they're actually receiving data from offsets, and they're processing different data, and one file lags behind, one is further ahead. They're completely isolated from each other. So this DAG stays deterministic all the time.
And one of the important parts of the DAG determinism is transactions. Do you have transactionality yet?
Transactions. So anyway, this is a good question probably to ask you. For the use cases that are going after, we're not going after transaction-oriented workloads. Transaction is a very complex topic. The more elements you have, and the more actually you have to store. So for instance, what does transaction imply? Transaction imply that actually you have to have you need the ability to roll back. You can imagine if you have a DAG with hundreds of elements on it, how are you going to be able to roll back all these elements in a very meaningful manner? It's one thing to actually guarantee you that when the data comes across, it's going to be consumed at the rate that it's consumed at. And it's another thing to actually have to roll back when one of the services is misbehaving.
Yeah. So what I would suggest there, or perhaps the question is, are you suggesting idempotency then as the best case or best practice?
That's what we're trying to accomplish. So the idea is that it's all the elements are idempotent, and we guarantee there's no repetition in them. So when you're building something, whatever you build it's been stored, but you cannot roll it back. You
And
can
just for
resume where you
those
left
that
off.
people, just for people that don't understand what idempotency is, I'll just define it real quick. Idempotency means if we had some data coming into our stream, into our function, and if there was an error here, there's an error down here, as he was just pointing out, that rollback of a transaction may or may not be able to be done right. Just because you rolled it back here doesn't mean you've rolled it back correctly right here. So just know that when you're, most of the transactionality we're hearing about from Kafka, etc., it doesn't really solve all of the problem. It's a kick the can problem. You kick the can to here, you kick the can to here, but it's a kick the can problem. So what I always suggest is an idempotent system, which means that if this fails and we retry it again, you can retry this 100, 1,000 times. The output state will always be the same, and it will always be the same down here and always be the same down here, and that's called an idempotent system. I highly suggest that, and it sounds like AJ suggests that as well.
Yeah, thanks, Jesse. It's a very good explanation. Actually, I should have done a better job like that. But the idea is that this SDF and the service chaining that we do ourselves is not meant for just a couple of elements and so forth. It's meant for dozens, for hundreds of elements that actually we're going to be able to chain and keep together in a stable manner for you. And it's building transactions for the use cases, at least we're going after, is not even, we don't find it's required. So for instance, imagine this, you do window processing, you do analytics. You're flushing that window every 15 minutes. After the window has been flushed, there's very limited value for it because the next window could happen a minute if it's just sliding window, or it's just if it's or 15 seconds later if it's a tumbling window. So that value of your data, it's very limited in nature. So then why would you want to implement transactions? So that's a question that we were trying to be practical about and find out, do we really want to implement transactions for the use cases we're going after?
What I found is that it was usually for more of the banks, more of that where transactions are a hard problem where we're used to pushing down to our frameworks those hard problems. For example, our database. We will throw a bunch of stuff at the database and we expect it all to be able to unwind or wind it. And so now when in this distributed system point of view, now we're expecting a system to do that for us, and that just really isn't. It may not always be possible, and so those who are either architects or what have you, this idempotency is a much better sort of architecture, and then you don't have to deal with not just the transactions. Transactions are just one part, but I would say a lot of the errors. Operationally, it becomes a significantly easier to operate system.
So from all the problems, the challenges we're actually solving, it's transaction is probably going to be the one that's going to be the last one to tackle. And the reason is because once you add it in, it's actually very difficult to implement to begin with. And once you add it in, everything you're building on top of that becomes exponentially harder. So it's one of the things we worked with banks as well with the early days, and what we noticed with banks is that they have different systems to tackle different problems. So for instance, they say, well, we don't even want you to do the duplication because we do the duplication with another product. But can I actually, after the item gets duplicated, I'd like to do a call out. So for instance, we can build this data streaming platform, and SDF does a lot more than just building you these tables. We are using WebAssembly under the hood, and we haven't even gotten to that. But where we are using WebAssembly under the hood, and that gives us the ability to enable WASI and do a call out to a database. For instance, one of the data pipelines we have in that we've prototyped, it does a call out in the generative AI. So you get a message coming in, and maybe it's a question from a robot, and you're trying to get an answer for generative AI. You actually do a call out through WASI, you get an answer, we join it to the data set and send it on its way.
Yeah, that's definitely something that's true. It's called an orchestrator pattern. You'll see that quite a bit. What AJ was just talking about, and that was here. Sometimes an SDF will make a REST call, and then it needs to efficiently wait for that, and that's a difficult problem. Do you have any suggestions on that? Because for example, you can't do the idempotent.
Yeah, so a call out. So just we are building an event-driven system. So everything is event-based with eventual consistency. We do not guarantee that things are going to be all the same all the time because it's an event-driven system. We guarantee that it will eventually get to stable state. So what you do with a call out, you typically want to do kind of a loopback mechanism. The message comes in, a record comes in, you do a call out, and ideally the system you're calling out to has the ability to call your webhook back. So then you join it for a data stream and join two data streams together to get the eventual results. So then you don't have to wait on it. You get an event coming in, you send a call out. When the response comes in, you take the same data store, the same item that actually have it stable in this arrow format, and enrich it. And
So
then you can decide to the business
so
logic
that
what
join
you
can
want.
be asynchronous then. You're not having to do window
Yes.
joins. Okay.
Yeah, you can do. Yeah, it's asynchronous. You don't do it immediately. You don't have to wait for response to come in. While you can do that, it's not that actually is going to block your system. And if the external entity fails, you end up in the same problems and end up in a service mesh. All of a sudden, you end up in a kind of a gateway situation where you have to wait for an answer before you can complete. But the better method in asynchronous systems is actually to do it asynchronously. Send the event out, let it process, get a callback back when it's actually get a callback when it's actually when the answer is being processed, and do a join when in to actually enrich your data set.
Okay.
And you can do that continuously with multiple callouts, and as your data actually progresses down the pipeline, it gets enriched, and it gets more and more insights.
Good.
So what we're building right now with this is actually, I'm sorry, I interrupted you, Jesse.
No, go ahead. You had something more interesting to say than I did.
So what we're building with this right now is a billing system. We're building our entire distributed billing system for InfinyOn because we actually have different geolocation on top of STF. So we have very interesting problems. One of the issues we realize that when you're building it in non-microservices fashion, in event-driven fashion, for example, we have billing, we issue your coupon, and then the coupon gets in the state store. Then when you apply your coupon, then you need to generate an email for you, tell you what has been applied and so forth. So we are building side effects for these tables. So when the table gets changed, all of a sudden you get a side effect being tell you, oh, somebody actually apply this coupon. So now let's generate an email. So then we create a new table saying for email generation. So the side effect reads that table, gets an event saying, okay, right, you should generate a table because I applied my business logic. I send it to the topic. The topic is going to pick it up, send it to an email connector, and off it goes, generates an email for you. So you can build very sophisticated systems on top of this SDF architecture.
Oh, you can. And it's in comparison to other sorts of systems, let's say you had a database and you're trying to do database polling, you really don't want to be creating those sort of database polling systems. An event-based system is significantly better for that.
Well, otherwise you end up in batch processing. And we have actually users right now that are moving some of the DBT payloads over to Fluvio because they end up in what they call DBT hell. They're just simply too many batch processes, and it's not useful. They're useful in some aspects when you're dealing with historical data periodically, but it's not useful when you're trying to react to customer behavior fast.
Well, maybe that's a good next question. Or let's go to 4 and let's talk about what are some of the applications. So you just talked about DBT hell. I would expect them to be in DBT hell, not because that, but because of the having to pay so much. But maybe they're in,
so
maybe there's other reasons.
So there are two application patterns that we're noticing out there, and there are two types of users that are coming to us. One is, so if I were to split the screen in half, the first architecture pattern you have is when you have the users that have Kafka plus Flink plus microservices, which we just talked about. These people, what they've done is they build their in-house tooling, and now they're saying, you know what, I'm not a Java shop. I left the company. I hated this. I just didn't really want to build Java. I didn't want to have to deal with all the complexity. I want to move to something that's a bit easier. I love Rust. I love Python. So I want to move to a stack that gives me all this in Python or Rust. Now we have Rust. We're building out Python next because it's WebAssembly. We're going to be able to build that. Now, the second pattern of problems, which is just alluded to, there are the guys that are using S3, and I call them S3 plus Snowflake plus DBT. This is much more common. And what I see is that this is the recommended stack nowadays. If you look at a lot of vendors out there and say, well, this is state of the art. Now, it may be state of the art for batch processing, but it's definitely not state of the art for real-time streaming. And you'll notice that now people actually have a cost issue with Snowflake and a cost issue with DBT. And you have to double store the data, right? And S3 as well, so you have a cost issue. And Snowflake is not that expensive, but moving data out of Snowflake is. So out of S3 into Snowflake is. So you are actually paying for this transformation quite a bit, for this transition quite a bit. So you're storing things in multiple areas. Now, there are a bunch of use cases that you don't really need the sophisticated data stack for. There are data streaming use cases when you want to actually build some level of correlation for events, or you want to do anomaly detection. Then all that stuff doesn't have to happen here. You don't want to do a batch processing and DBT to identify anomaly detection that happened like an hour ago. You actually ideally are able to identify the anomaly detection if a particular is based on an event right away, or even if it's a chain of events. Now you can use STF to bring this together. So in this case, is what we're seeing now is that people are actually moving over from some their DBT workloads and ask us whether they have a solution that they can build these workloads for anomaly detection, build a work for some simple analytics to the data streaming itself. So that's where you have Fluvio plus STF. And in cases where you actually want to, SDF, there's another component that we're building into the system. It's called the hub. And the hub gives you the ability to take those packages and the data flows and publish them together so you can share. This is really the data hub. So now we see people coming from DBT, as I mentioned, to Fluvio for cost savings and for the ability to get answers or insights or anomaly detections faster.
A question here especially on this Snowflake side. So these DBAs, they won't know any programming. Do you have a SQL interface that allows them to be productive?
So a very good question. It's a development platform first. Now, we didn't build out the SQL interface yet, but we are, as we're working our way towards analysts, towards people, they're gonna say, you know what, I take your data flow, and I don't really need to load coding because all I'm interested is in the insights. Then they need a SQL interface. So for that, the beauty of it is that we are actually, as I said, we're converting this to Arrow and we're exposing Polars. Now, Polars has a native SQL interface. We just have to do some work to give you the ability to use Polars in SQL instead of using it programmatically. So that's a roadmap item for us.
So it's almost as if here in kind of parentheses is over to the side there is DuckDB so that they can run their queries.
Right. So it's it's DuckDB. Yeah, you wrote it over there. I wrote it in here. So in SDF, you'll be able to run DuckDB or Polars to run your queries. And since it's Arrow format, a lot of that comes from the third-party product itself.
Interesting. And you mentioned Rust, and I didn't point it out we didn't talk about it specifically, but you kind of alluded to it, that the issues that you have with the JVM. So with Rust, what is Rust giving you on this system?
Oh, there's so many benefits to Rust. It's like I could probably spend a bunch of time on it, but very high level. You get speed of development. I mean, Rust is a language that it's really, there's stories behind it. Why did we pick Rust? But I don't know whether we're gonna have enough time to go over it. But the idea is that you get speed of development. In Rust is actually it's a well code, a good architect. You write the code once, you deploy it, and 99% of the time you're not gonna have bugs. So that's the thing that we've discovered when we moved to Rust. Our speed of development is amazingly fast compared to previous system when we build either JavaScript or C++ and so forth. Code safety. You don't have to worry about security vulnerabilities as you worry with the C++ system. High performance at P99 in particular. As you might have heard, Kafka has issues at P99 in particular is where garbage collection kicks in because you didn't tune the system properly. Now, Rust doesn't have that. You can get P99 performance, and it just works just as well at P99 as it works at 1%, for instance. Code size. Our binary size is 27 meg. If Kafka binary without Java is 350. It's, as you can imagine, if you have edge deployments, which we have towards the edge, because we're just building mirrors for that particular instance, we can run the whole stack on a Raspberry Pi. That comes back into, it compiles natively in a lot of different architectures. So we can compile the stack in ARM64, in ARM32, we can compile it in x86, and it just as easy to do it in any one of them. We have, I think, 8 different binary packages, or 10, I don't even know. When we're packaging it, we have all sorts of different operating systems that we're compiling against, and all that comes out of the box because of Rust. As I mentioned, no garbage collection and memory usage. In order to run our system, you can run our system as little as 50 meg of RAM. With a Kafka, it's recommended 2 to 4 gig. So we're getting a lot of benefits from Rust that we could do the things that we do if it hadn't been for the programming language.
Okay, I'm gonna follow up on that because that is an interesting thing. So we have that Rust, and that gave you some interesting parts to it. Were you having any trouble finding Rust programmers, or did you just have your team learn Rust, or what happened there?
Oh, we don't have time to train anyone. And in the early days, maybe one of the things I should share, we had quite a bit of debate between my co-founder and I what development language we were going to pick. He wanted to pick Rust, and I wanted to pick Go. I felt like Kubernetes is building Go. We will build a cloud native product. Therefore, it should be Go as well. Lots of other companies are building on top of Go. Well, ultimately, he was the technical architect, so he got the final say. So we went with Rust. Now, 5 years later, I can say that it was the best decision we could have made. If it hadn't been for Rust, we would have ended up probably in a different place. And I'm very thankful for that. Now, in terms of Rust developers, well, it's not the easiest bunch you find because it's a small community. It's not as big as it would have been if you actually build this in Go, for instance, or you build it in JavaScript or Python. Right? They have huge communities. That being said, the developers that we find in Rust is not an easy language to pick up. So when you find good Rust developers, these guys are brilliant. For instance, we have a team in South America, some brilliant Rust developers. We had a team that's from Eastern Europe, which has brilliant Rust developers, and it's a blessing in disguise. It's hard to find them, but when you get them, they're really good.
I haven't had much time to either go down that Rust path and see it. I've seen some Go code. It was fine. I don't think it was as amazing as people are saying it, but or perhaps the code that I saw wasn't very amazing either. But yes, I'll have to check out Rust some more, see what's going on there. So go ahead.
One thing I may want to add is probably we build one of the largest open source projects in the planet. We have in total close to 200,000 lines of code. So if you look at GitHub, we are probably one of the largest projects out there. If you're interested in participating in the product, that actually it's really enterprise quality and it's large, and you want to learn how it is to actually build a large Rust project, I think Fluvio would be a good place to start.
Oh, good recommendation for everybody. So you mentioned that your Python library or your Python client isn't done yet. Is Rust the only client library that's available for writing your own code?
Okay, so if we go on the other page briefly, I can show you a few things. So I identify things, not the page. Let's go to page number 2.
Okay, I'm going to page 2.
Yeah.
Okay,
the reason I want to bring it here, so I kind of start segmenting things. So for instance, on the connectors, we build them in Rust, but you can build them in other languages themselves. The clients, we have 5 clients, 5 programming languages but there are only 2 officially supported. So we have full support for Rust, and we have full support for Python. We have partial support for JavaScript, and we have some community supported. Erlang, somebody added Erlang, somebody added Go. So the clients, we support multiple languages. Now, where Rust and Go comes in is WebAssembly. So if you look at this bounded context, all the stuff that we're doing in here into STF, STF is when we're writing. So when you talk about the bounded context, the STF and smart modules, they talk about WebAssembly. So WebAssembly currently we support Rust, and we are in the process of integrating Python on it. So when we do transformation on the system itself, not the edge, You can do it in Rust alone, and we'll integrate Python. But when we actually ingest data into the system, you can do it in Python, you can do it in Rust, you can do it in JavaScript, and you can even do it in Go and Erlang if you don't mind spending some time updating those clients.
Okay. So that would mean that that people deploying the system would experience the same sort of difficulty of finding good Rust developers to write these packages for themselves, for example. So do you provide that service then?
We do both. So one thing we noticed, and it's actually was fascinating for us to watch, when we told people, "Oh, sorry, we only have Rust. Oh, we're a Java shop." We were fascinated to find out that people, the business logic you're typically building is not large. We built the system with 100,000 lines of code or 200,000 lines of code in Rust, but it doesn't mean that you have to write your business logic. And I can show you some examples if we have the time on from GitHub to show you how small of a snippet of a code it is to run really sophisticated logic. So people find fascinating to learn Rust for the business logic you're trying to apply. Just this last week, I talked to a guy that actually is doing billing and he's actually using Go under the hood. And he said, "Oh yeah, for the business logic that I apply, it shouldn't be that hard to pick up Rust." So they're doing that in Rust, or we're gonna apply Python. We're gonna enable Python in the next maybe few weeks. So we give you the ability to data engineers to use Python, because these people are they prefer Python and they will not go anywhere else because they're using Python everywhere else in their system. So those are the two options that you will have.
Okay. So seeing as we're running low on time, what is most exciting to you about your roadmap right now?
Well, as I've shown you here, actually, what you might have not come across, SDF is a new thing. Like state to data flows is something that we have not really launched. If you go to our website and you take a look there, you're not going to see anything about it, because we plan to launch. And actually, I kind of made an announcement in this podcast that we're doing it. It's the first time we really talk about it publicly. So the most exciting part for me is that we're going to be deploying this SDF, and it does a lot of things that we talked about already. It's just currently in preview. Is not yet recommended to run in production workloads. Therefore, and we're still working with design partners that give us feedback. So that's the most exciting part, to get this launched, to be able to accomplish some of the use cases that I just described on top of Fluvio itself.
Well, given my experience with the Flink equivalent of this, the biggest difficulty was was moving from one version of the object to the next. So that migration, that schema migration, they put a lot of effort into that, and I'm not sure if they're done with that. Did you think about that and how you'd handle it?
Everything for us is versions. So we have types. The types are versioned. We have uh, we have packages that are versioned. Of course, transition from one version to another, if you actually build your own business logic, is up to the developer. But you have all the constructs in place to transition from one version of the package, one version of the schema to another.
Oh, good,
So all that
good,
we built for the ground up. We've gotten feedback very early on that that's actually that's actually very important, and we've built the system accordingly.
excellent. Well, I have a few more questions for you. Since you've done so many acquisitions, do you think that there's a formula or method for creating technical businesses that get acquired?
Oh well, that's kind of a difficult one, because I don't know whether we are a recipe for success when it comes to speed. Um, we are infrastructure, and when you're building an infrastructure component, you want to make sure that you're in for a long term. I mean, we have been at this for 5 years, and we are seeing. It's just been a few months since we're seeing the escape velocity we thought we are going to see a lot earlier on. Why? Because we're actually building three products. We're building streaming, we're building stateful processing, we're building the ability to programmability online, we're building the DAGs that you mentioned. So all that takes a long time to do. So infrastructure time consuming. So if there is one lesson that I learned from this, is that if you build an infrastructure product, you have a few things that are going against you, and you want to make sure you think this through. you have to make sure that your technology stack is actually pretty solid. It's not that it's hard to build, but it also has to be reliable, because what you're asking your users to do is put the faith into you. Give me your core assets to transform, to actually run them through our system. If that system fails, your business is handicapped. So you want to make sure that when we're building this technology, you're building it very solid from day one. Second, customer validation. Pick a business that allows you to do customer validation faster. It's like you don't want to build for 4 years like we've done in order for you to get the validation. We've got the validation earlier, but validation has always been you got to build more because this is only solving part of the problem. Pick a business that it gives you the ability to 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 just validate faster, to have a smaller footprint, smaller surface area. It may look like it's an initial tool to something else, but it gives you faster rollout. Hopefully, it gives you the ability to roll out something without asking your customers to take a huge amount of risk. And third is focus on customer validations early. And if, as an infrastructure, people nod their heads, oh, I love this, but I cannot make a commitment until I run it for a while and make sure it's stable. And therefore, pick smaller companies that are willing to move fast. Pick the ones that have a simple technology stack, so you don't have to build a ton of connectors before you get you going. So these are the things that I would lessons learned from us. If I were to do it again, I would have probably started from a tool. I would have started from what Rising Wave has done, just build stateful processing first, and then augment towards the rest of the areas. But that being said, if you start from the top and you try to work your way to the bottom, chances are you're going to end up with a different product. And it would not have given us the ability to build what we're building today, because you're taking advantage of a lot of the infrastructure and stream processing that we spent 3 years building in order for us to build the stateful data flows. So maybe it's a long-winded answer, but the whole idea in here is that pick something smaller, get it validated, and if you build infrastructure, prepare for longevity, because it will not be fast.
And as we saw from your background, you went from heads down coder all the way to founding your own business. What advice would you give others, I guess non technical, more career advice, to found that business?
I think curiosity. I was always curious. I was always trying to solve problems, to solve technical problems. I was always curious to be on the lookout for things that haven't been solved yet. If you really want to start your own company, you have to ideally identify a problem before you left your job. So use your spare time wisely. Identify areas that you believe haven't been solved yet and test them. Go talk to prospects out there. Go talk to people where it's a serious problem, where it's a problem they're willing to pay for. Ask for a check, ideally, before you even leave the building. Ask them, say, yeah, look, I go out there and build this. Would you sponsor it? Is it going to be painful enough to pay for it? And get a few people to say, okay, yeah, I'll write a small check, either as an investor or as somebody says, you know what, I'll, I'll, I'll pay for it because I believe in it. And I believe you're going to make it, you're going to give me a product I can use in the near term. So that's the thing that I find valuable. Lead with curiosity, find a problem that you believe hasn't been solved, validate it through in lots of different places, because you'll be surprised sometimes the answers you get when you talk to people. You start here, you may end up there. Maybe it's even a better problem that you didn't think of solving. And then ask for the check, ask for money up front before you leave your job. That will make your journey a lot easier than just walking your way into the wild, go fundraise, build a product while you're fundraising, try to build a team at the same time, and so forth. It's a grueling it's a grueling journey, but for us it's been fun and it continues to be fun.
Well, AJ, it's been a pleasure. I really appreciate you sharing so openly and talking about your products. Thank you so much for being on the show.
Thank you, Jesse. It's been a pleasure.